This is our second PLDC assignment, the contribution of extensible markup language towards the field of science. These are our group members. In our previous presentation, we described the contribution of the extensible markup language towards the field of business. In this presentation, we describe the contribution of the extensible markup language towards the field of science and technology. XML is a meta-language, a language for creating other languages. In this presentation, we discuss notable markup languages that have been created using XML. These are some of languages formed by XML. Mathematical markup language. Until recently, mathematical expressions have typically been displayed using images or specialized software packages such as text and LaTeX. MathML was developed by the W3C for describing mathematical notations and expressions using XML syntax. It enables document authors to describe mathematical expressions that can be processed by different applications for different purposes. This flexible promotes wide reuse of mathematical content over many domains. MathML version 1.0.1 is the current W3C recommendation. OpenMath. OpenMath is an emergent standard for describing mathematical content. Although MathML does provide a set of semantic elements, it is mostly limited to describing the presentation of mathematical expressions. OpenMath content can be embedded in MathML, synthesizing the description of mathematical content and presentation. OpenMath represents mathematical expressions with objects that can be exchanged between different software systems, manipulated in databases, displayed by different applications including internet browsers, used in different contexts, and even checked for mathematical correctness. The standard itself includes specification of binary and XML encoding of OpenMath, extensible libraries of OpenMath objects, and libraries defining semantic content. An OpenMath object has three layers of representation: as an application-specific entity, as an abstract of OpenMath object, and as a byte string for communication purposes. The content dictionaries define the meaning of an object so that an application can convert it into an internal representation. Software is currently being developed to utilize and support OpenMath, as it has great potential in many industries involving manipulation of complex mathematical expressions. Chemical markup language. The chemical markup language is an XML-based language for representing molecular and chemical information. Many of the methods previously used to store this type of information inhibited document reuse. CML takes advantage of XML's portability to enable document authors to use and reuse molecular information without corrupting important data in the process. Wireless markup language. The wireless markup language is an XML-based language that allows web pages to be displayed on wireless devices such as cellular phones and personal digital assistants. WML also has a companion scripting language, WML script, which is based on the ECMA script standard. WML works with the wireless application protocol to deliver this content. WML is similar to HTML but does not require input devices such as keyboard or mouse for navigation. A WML document is called a deck and contains static parts called cards. Each card consists of one page of information, providing the WML browser with a small self-contained document for browsing. This packaging of multiple pages of information is necessary because the devices to which WML is delivered have limited connection to the internet. WML include telephone elements so that secure telephone functionality can be implemented with WML script. For instance, a voicemail service can have a WML user interface that gives the users choices about their mailbox. WML also has image support for devices that can display bitmap graphics. Geographic Markup Language. The Geographic Markup Language was developed by the OpenGIS Consortium. GML separates content from representation. GML describes geographic information for use and reuse by different applications for different purposes. In GML, geographic information is described in terms of features. A feature is composed of properties and geometries. GML properties contain name, type, and value elements. Features are geometric entities. Geometries contain the bulk of geographic data, and properties argument that data with descriptive information. That's the end of the part 1. Part 2 will follow up.